Okay, guys, so today we're going to go over 2.5, which is transformation. So in the previous section, hopefully you guys have done it, looked at a few graphs. What you've been working on is the library of functions. So now you kind of have an idea of what functions look like in general, like their base function. A lot of times those functions that you memorize from the library of function, you'll call those the parent functions or guide functions. So today we're going to talk about transformations, and the first thing I want to talk about is a vertical shift. So a vertical shift of y equals f of x is done by adding a constant k. So think of it as y equals f of x plus k. So f of x, whatever it was, would be shifted up k units. If k is negative, then it would be shifted down k units. Okay, a horizontal shift. So a horizontal shift is done for y equals f of x when you subtract or add h to the function inside, f of x minus h or f of x plus h. So right here we have y equals f of x minus h, and when we do that, we're going to shift to the right. So notice that it's a minus sign, so you actually take the opposite sign, and it has to do when you plug in the value that would make the inside 0. So you always think whatever's inside the function, you take opposite. So like this one, you see how this is plus h, then you would shift to the left, right? So we would shift to the left h units. If it was minus h, then we shift to the right. However, when you're doing a vertical shift, this is not inside the f of x. So this actually just causes it to shift up or down the same units of whatever the sign is. So if it's negative, you shift down that many units. If it's positive, you shift up. So that's one of the main things you have to learn. And many of you, once again, have seen stuff like this. We're just kind of refreshing it. Okay, so suppose we want to use the graph of y equals x squared to guide us for the following functions. Okay, so in my mind, this is my guide function. I know that y equals x squared is this, right? That's the basic parabola, right? So that's a basic parabola. That's the basic parabola, right? I kind of drew it bad, but you guys get the idea. For this problem, that's the basic parabola. Oops, it's kind of ugly. That's the basic parabola. For this one, that's the basic. So for all of those, the red is y equals x squared. Y equals x squared, y equals x squared. That's our parent function, right? So what we want to do is we want to take that function and we want to shift it to the left, to the right, up, down, whatever the case may be. So this particular problem has a -2. So we are going to shift, and it's inside with the x. We're going to horizontally shift 2 units right. So what I'm going to do is I'm going to say here's 1, here's 2, and then I'm going to attempt to draw the exact same parabola. And again, it's not identical, but it's supposed to be the same. So I'm drawing the exact same parabola, and it's just shifted to the right 2 units. Now this one, there's nothing inside with the x squared. So that means that when you say +2, you are only shifting it upward. So I'm going to go up 1, 2 units. So we're going to shift up 2 units. So then we do this. Right? So we draw the exact same parabola. And again, I'm not great at drawing perfect shape. So we'll shift up 2 units. Okay. But again, it's all about the guide function tells us what it should look like. And then we move it around based on that. So it's literally like somebody's picking it up and moving it around. So this one's pretty bad. Oops, geez. Okay, so now we're going to do the same thing. This is our guide function. Now this one has a horizontal and a vertical shift. So we're going to say that this has a horizontal shift, 3 units left, right? Because it's a +3, we go to the left direction. If it was a -3, we go to the right direction, okay? And a vertical shift of -1 unit or 1 unit downward. Okay, so because it's a vertical shift, we don't flip the sign. We just go with, if it's negative, we go down. If it's positive, we go up. For the inner function right here, for x +3, we take the opposite sign always, okay? So we want to do a horizontal shift of 3 units to the left. So 1, 2, 3, and then we're going to shift 1 unit down. So 1. So I'm right here, and I'm going to draw the exact same parabola. Oh, that's terrible, but you guys get the idea. I'm drawing the exact same parabola that is shifted to the left 3 units and down 1 unit. Okay, so hopefully you guys are getting the hang of it. Pause the video and just make sure that you guys can do this one on your own. There's going to be quite a few of these in the homework. So just give this one a shot. All right, so hopefully when you unpause the video or when you pause the video, you did this. You said that this has a horizontal shift 1 right and a vertical shift 2 up. So I'm going to go over to the 1. Let's see here, maybe not over to the 1. Let's go over 1 and then 2 up. 1, 2. So right there, that's where I'm going to start, and then I'm going to draw my parabola just like that. Okay, so again, it's supposed to be the same parabola. I'm not super good at drawing, but you guys get the idea. There should be no difference between the 2 parabolas, just moved around. Okay, so there's something else that we can do. So for part A, B, C, D, E, so for part E, we're going to look at compression and stretches. So this will be a vertical stretch and a vertical compression, okay? So if A is greater than 1, okay, or I should say the absolute value of A. If the absolute value of A is greater than 1, then the original function so if it's greater than 1, the original function is stretched vertically by a factor of A units. Okay. If the absolute value of A is less than 1, meaning it's a fraction like 3/4 or 1/3, okay, then the original function is stretched. Oops, not stretched, sorry, compressed vertically by a factor of A units. Okay, so this is a fancy way of saying if I gave you guys, let's say that I gave you guys, let's see, f of x equals, you know what, let's do this. Let's do y equals 1/2 x squared. Okay, so when I go to draw the graph for this, I'm going to draw my parent function, which would be this, right? That is the, oh my goodness, that is not good. Okay, well, that's as good as it's going to get for now. Maybe I can shade it in and it'll look better. Nope, looks worse. You guys get the idea. We have a parabola, x squared. This is y equals x squared. Now, in this case, A is the number in front. So A is always the number in front, okay? So when you're dealing with these situations, A is always the number. Your book kind of talks about it differently. So we're going to get into this more in other sections, especially with parabolas, but it's basically what the function is being multiplied by, or what the function is being multiplied by. So A will be this number. So in this case, if I say 1/2 x, okay, that means that I'm going to take and I'm going to stretch or compress. Well, the absolute value of A, absolute value of 1/2 is actually less than 1. So this means that this is compressed. So then I think of it as a wider parabola. So it still looks the same, but it just becomes wider. by a factor of 1/2. Okay. So if I did the same problem, y equals 2x squared, and then I drew my graph, I would have my normal basic parabola, y equals x squared. Oops. Jeez. Okay, so we have that. That's y equals x squared. So then I'm going to now, because I have the absolute value of 2 is greater than 1, that means that I now am going to stretch it. So it becomes a skinnier, narrower parabola. Okay, so that's how you can adjust that. Okay. So the reason I'm focusing on parabolas is just because it's the most common way to deal with it. So what we can then do, or it's something that we're going to spend more time on, is we can consider other shapes. So what if I wanted to do, no, I don't know. What if I wanted to do y equals, y equals absolute value of x plus 2 minus 1. So I know that the normal from my library of functions, I know the normal absolute value function looks like that. That's the basic y equals absolute value of x. So what I'm going to do is I'm going to take that same function and I'm going to shift horizontally 2 units left and shift vertically 1 unit down. Okay, so now that means I take the same exact shape and I shift it 2 units to the left, 1, 2, and then down 1 unit right here. And then I draw my same exact shape of a V, but now it's shifted. Okay, so there's something else that we can talk about, reflections. So what if, let's see here. So what if I had, so reflections. So reflections are a little bit easier, but at the same time, sometimes they don't turn out how we think. So reflections, let's say that I have y equals negative square root x, okay? So normally, if we were to graph this, here's what the normal square root of x looks like from the library of functions, right? That's y equals square root of x. But now think about it. There's a negative sign in front of this. So that means that if I'm going to draw this one, I have to think that it's going to be the exact same shape, but now all of my values are going to be negative. So when I put 0 in, I get 0. When I put 1 in, I get negative 1. So when I put 1 in, so I put 1 and I spit out negative 1, right? Let's say I put 4 in. So I go 2, 3, 4. When I plug 4 in, I get square root of 4 is 2, but then it becomes negative 2. So if you notice, oops, it's going to turn out to be, well, kind of doesn't look like it, but it's going to be the same shape, but down here, okay? So this would be y equals negative square root x. So reflections across the x-axis occur when you put a negative in front of the function, okay? Now, what happens if we do y equals the square root of, let's see here. Let's try negative x, okay? So take a minute, pause the video, see what you think this would do, okay? So I'm gonna take out my calculator and just kind of show you why we don't spend as much time on this as we used to, because now in my mind, I already know what square root of x is supposed to look like. I know what square root of x is supposed to look like. It's supposed to look like that. But now I'm gonna put a negative inside there. And it would actually reflect it across the y-axis. So now we do like this. Same exact problem, or the same look, but now reflected across the y-axis. So this is just something that you kind of have to play with a little bit. In general, reflecting across the x-axis is the easiest because it's just telling you that whatever you used to get, you're now going to get the negative version of it because somebody put a negative in front. And that's why that one's kind of easier to understand. Sometimes it's harder to see when you put a negative x inside the function, what it's going to do to it. But again, a lot of this stuff you guys can just use on your calculator and kind of verify. The important thing is that you understand that the guide function or the parent function kind of dictates where you're going to move it around to, or what. When they say reflect it, they're talking about reflect what? They're talking about the original parent function reflecting, or the original parent function transforming it, moving it left, moving it right, compressing it, uncompressing it, you know, anything like that. So let me just have you guys look at a couple more. Okay, let's see if we can have, if I have one that does a little bit of everything. So let's do this one. So suppose I gave you y equals, so let's say graph using transformations. And again, all of these things are called transformations as like a whole. The main ones we think about are vertical and horizontal, but it's kind of a family. These are all things that are called transformations, or all ideas. Graph using transformations. So let's say we have f of, not f of x, say we have g of x is equal to -3 x minus 2 squared plus 1. Okay, so what I'm going to do is I'm going to go and put my graph over here. Oh, geez, that's pretty bad. Put my graph over here. 1, 2, 3, 4, 1, 2, 3, 4, so on and so on. Okay, so I'm going to draw my parent function. My parent function is the normal basic parabola, right? Oh, geez, I can never get it. Okay, so we have that parabola. Okay, now what we're going to do is we're going to think of our shift. So we're going to horizontally horizontal shift to right, vertical shift 1 up, and since absolute value of -3 is greater than 1, we have a vertical stretch. And then we also know that since a is negative, it reflects across the x-axis. Right, so basically what it's saying, or it's the downward facing parabola, so we're going to get something like this. So let's reflect it first, okay? So we're going to say, well, it's going to be this guy like this, right? But now we have to move this guy around. So now I'm going to move that to the right 2, 1, 2, and then I'm going to move it up 1. So that's right there. And then that would be now the correct answer. But then we also know that it is even more so, it is now stretched. So somebody takes it and makes it really narrow, okay? So then this is going to be like this. So all of these are actually not even part of the drawing, right? They're just guides, they're to help you. So this is the actual function. And then what you can do is you can take out your calculator and verify this. So I'll take out my calculator and I'll do y equals -3 parentheses x minus 2, close parentheses, and then square it. Oops, plus 1. Yep, and that's it. That's what I get on my calculator. So I just verified it. And again, your calculator can do a lot of this. So it's important that you know how to use your calculator, but it's also important you understand why it's moving around like this. It's based on the library of functions, the base functions, the parent functions, and then you move them and shift them and do whatever you need to do. Okay, I think that'll do it for this video, guys. Definitely a section that the homework will help a lot, because there's not really a lot of work for this. It's more you understanding how to move things around. Okay, so that's going to be it for this video. Thanks for watching.